Today we're going to look at how to differentiate any function which involves y equals e to the x. The derivative of y equals e to the x is in fact itself. It's y equals e to the x. And this can be proven from first principles, or you can just look at what happens when you look at a base between the numbers 2 and 3 and have a look at how the derivative just converges to sit on top of e to the x. So what I'm going to do is just differentiate any function that involves this. Let's start by looking at y equals e to the 5x, for example. This we can break down into two simpler functions and apply the chain rule. We can say that this is y equals e to the u, and let u equal 5x. Now, as the chain rule states, we differentiate each of our individual simpler functions, so we get to y du equals e to the u, and du dx equals just 5. Multiplying the result of these gives us to y dx. So when I multiply e to the u multiplied by 5, I get 5e to the u. And now we must remember to substitute u back in, and u of course equaled 5x. So our derivative becomes 5e to the 5x. Now if we have a look at this, can we do this any quicker by using a short rule? Well, if we had e to the 5x, what we notice here is the derivative of the other simple function up here is actually multiplied by the whole derivative of the entire f of x. So we pull the 5 down to the front and we end up with the derivative. Now let's see if that works for y equals e to the x squared, for example. Y equals e to the x squared. Well, applying the rule that I've just learnt down here, what this should be is the derivative of this should be multiplied by the whole derivative. So the derivative of just this power part is just 2x. So we think the derivative will become 2x e to the x squared. Okay, now let's check it by using the longhand version of the chain rule. I'm just going to clear some space here. All right, let's apply it. So here's our e to the u. So we let y equal e to the u, and we let u equal our power, which is x squared. Differentiating this, e to the u just becomes e to the u, and differentiating this one becomes 2x. Now we multiply the result together. 2x multiplied by e to the u, and remember to substitute our original u back in to finish the derivative off. And of course, we're left with the same result. So what we can in fact do is now use the shorthand to do some derivatives. So let's just do one more. Y equals e to the 2x plus 1. Well, our power is 2x plus 1. So if we differentiate this, we get y dx equals, well, the derivative of the power is just 2, and then we keep the function itself, e to the 2x plus 1. Hopefully, you've got a little bit of an understanding of how to differentiate anything that involves y equals e to the x